Okay, so let's recap the lesson. So in triangles, there's two particular triangles that are really unique, and one is this 45, 45, 90 triangle, because a 45, 45, 90 it's half a square, right? So if it's half a square, we know these two sides have to be equal, it's a square. So then, instead of doing Pythagoras' theorem, it's just faster if you know it's 45, 45, because these two sides are equal, and this is always whatever these are times the square root of 2. So in example 1, I mean, if this is 8, that's got to be 8. And then this side, without going 8 squared plus 8 squared equals c squared, it's just 8 squared to 2. It's so much faster. It is 8 squared to 2, which is 8 squared to 2. You could either take this decimal, which or you could take this answer, 8 squared to 2. So it's just a shortcut, so you don't have to do the Pythagoras theorem, okay? Example 2 works the same way, except for we know the diagonal. Diagonal this time is 18 squared to 2, which it sits as a something squared to 2. So these two sides are going to be 18 and 18, okay? Only because it's a half a square, which makes it a 45, 45, 90. Now example 3 is a little bit unique because right here we should have, look at this, x squared to 3 right here we should have, but it's a 12. So the 12 is sitting where the x squared to 2 are. So if we need to find x, we just solve. Okay, if I'm going to solve and set 12 equal to x squared to 2, and I want to solve for x, I divide by the square root of 2, divide by the square root of 2, and 12 divided by the square root of 2 is 6 square root of 2. So these two sides are 6 square root of 2, 6 square root of 2. Okay? Now, let's turn on the back. So now there's also one other unique right triangle, and that's what we call the 30, 60, 90, or 36, 90. Same triangle, it's just drawn differently, okay? Turns out that the hypotenuse is always twice as big as the short leg. So for example, 10, this would be 5. 18, this would be 9. And then the longer leg is whatever the side is times the square root of 3, okay? Same thing here. It's just on its side. The hypotenuse is always twice as big as the short leg, and the short leg is whatever this number is times the square root of 3. So here's my example. Okay, I've got my 12, which is twice as long as the short side. So this is 12. That's got to be 6. It has to be 6. And then this side is this 6 square root of 3. And I like that answer, 6 square root of 3. It's much better than this answer because that's an ugly decimal answer. I'd rather have 6 square root of 3 than 10.39. Okay? Faster than the Pythagoras theorem. Okay, example 5, same thing. Here's your 18, which has to be twice as big as the short leg. So 18, that's going to be 9. And this is going to be 9 square root of 3. 9 square root of 3 is much better than using Pythagoras theorem. It's just faster than 15.5888. So it's just 18, 9, and this is 9 square root of 3, okay? Okay, then finally we did a little problem that dealt with finding the area of this triangle. We are given only this, because I've drawn on it, but this is 10, 10, and 10. What we recognize, if we want the area is 1/2 base times height. I know the base of this triangle is 10, so I can put 10, but I don't know the height. So I drew in the height. And now what we saw was the fact that it broke it into a 30, 60, 90 triangle. And if that's 10, that would be 5. And then this height is 5 square root of 3. So now I know the height is 5 square root of 3. So I can go then and my base has my height, 5 square root of 3. And I get an area of half of 10 is 5. 5 times 5 is 25. 25 square root of 3. Or if you want a decimal, you can. 43.3. Okay, and that's all I had. We had a worksheet today for homework lesson 9-2. Okay, that's it.